All right, let's dive into one of the biggest, sneakiest problems in data engineering, why your Azure data storage is so slow and why your cloud bill is so high. We're going to architect a solution moving from a costly mess to a sleek, optimized system.
Have you ever gotten that cloud bill at the end of the month, looked at the storage costs, and just thought, what is even happening here? You're definitely not alone. A huge part of that cost isn't just about what you're storing, it's about how you're storing it. And today, we're going to fix that.
So let's set the scene. Imagine your company's app is a massive hit. You've got millions of users, and they are generating a constant, massive stream of telemetry data. Every click, every swipe, you name it. This is a gold mine of information, right? But it's also a data tsunami that's about to completely swamp your systems and, you guessed it, your budget. It's a good problem, but it's still a problem.
Now, to handle all this data, you've probably built a pretty standard pipeline. The data flows from the app, lands in your data lake, something like ADLS Gen 2, gets crunched by Databricks or Data Factory, and then served up in Synapse for querying and Power BI for pretty charts. Look, this is a totally solid modern tech stack, but the devil, as always, is in the details, specifically in that storage layer.
Okay, so let's look at the first attempt. We'll call this Pipeline 1. This is the path of least resistance, the one a lot of teams take when they're just trying to get things working. But as we're about to see, this easy way is actually incredibly inefficient and really, really expensive.
The architecture here is, well, it's simple. We just get the data and dump it. We end up with this one single, gigantic folder in our data lake that's just jam-packed with thousands, maybe millions, of tiny little JSON files. Seriously, picture a warehouse with no shelves, no aisles, nothing. You just open the door and throw everything into one massive pile. That's our data lake right now.
So here's the anatomy of our problem. These are the design choices that got us here. A single data dump folder, a row-based format like JSON, and thousands upon thousands of tiny files. You know, each one of these decisions seems kind of harmless on its own, but when you put them all together, it's a perfect storm for terrible performance.
Sooner or later, the business is going to come to you with a question, and it's a totally reasonable one. Hey, can you just tell me how many unique users were on the app last Tuesday? This is like Analytics 101. So let's see how our messy Pipeline 1 handles this simple request.
15 minutes. I'm not kidding. That's how long it takes. Can you imagine being the analyst, just staring at a loading screen for a quarter of an hour to get a simple count? And why? Because the query engine has to individually open every single one of those thousands of tiny files and scan through all the data just to find the handful of records from last Tuesday. It's a nightmare of inefficiency.
And the cost?
Oh, the cost. That 15 minutes of compute time just cost you $50. 50 for one query. Now imagine you have 10 analysts and they're all running queries all day long. You can see how this spirals out of control into thousands, even tens of thousands of dollars a month. This just isn't sustainable.
Okay, that was painful to watch. But that was the problem. Now, let's talk about the solution. It's time to take a step back, put on our senior architect hat, and look at the playbook. There are 3 core principles that will completely change the game here.
First up, partitioning. This is huge. Instead of that one giant messy folder, we're going to create a clean, logical folder structure. Think year, then a subfolder for month, then a subfolder for day. Now, when we ask for data from last Tuesday, the query engine is smart. It knows it can completely ignore all the other folders. We've gone from that messy warehouse pile to a perfectly organized filing cabinet.
Second, we're ditching JSON for something called a columnar format, like Parquet. See, a JSON file stores data row by row. So to get the user ID for our query, you have to read the entire row, every single piece of data, just to find it. But Parquet is clever. It stores all the user ID values together in one block. This means our query can just zoom in, grab that one column it needs, and ignore literally everything else. It is a massive game changer for performance.
And finally, we have compaction. That small file problem we talked about is a real performance killer. There's a lot of overhead just opening and closing thousands of files. So compaction is a simple process where we periodically combine all those tiny files into a smaller number of larger, more optimized files. It's just good housekeeping, and it makes reading the data so much faster.
Okay, so we have our 3 principles: partitioning, columnar formats, and compaction. Let's apply them and build Pipeline B, our smart, optimized architecture, and see just how dramatic the difference really is.
Just look at the difference. The data dump is gone, replaced by a clean, partition folder structure. We've swapped out inefficient JSON for high-performance Parquet. And we've implemented compaction, so we have fewer, larger, much happier files. Every single choice here is intentional. It's designed for speed.
So this is the moment of truth. Let's run the test. The exact same business question from the exact same analyst. But this time, we're pointing it at our new intelligently designed pipeline. What do you think happens?
The results are just staggering. The query time drops from a painful 15 minutes down to just 8 seconds. And the cost? It plummets from $50 to 75 cents. Let that sink in. This is not just a small improvement, it's a complete transformation. We made the system over 100 times faster and almost 70 times cheaper just by making a few smart decisions about how we store our files.
So the crucial point here is that this isn't some kind of dark magic. It's just good engineering. And to make it really easy for you to apply these lessons, we've boiled it all down into 5 simple, actionable rules to live by.
Okay, here's your cheat sheet. Rule 1, partition everything. It's the single best way to avoid scanning data you don't need. 2, embrace columnar formats. Make Parquet your best friend for analytics. 3, actively fight that small file syndrome by building a compaction process. 4, and this is a big mindset shift, always design for how the data is going to be read, not just how it's written. And finally, Rule 5, the most important one. Remember that your storage layout is your compute performance. They are not separate things. They are 2 sides of the very same coin.
Look, making these changes will fundamentally improve your pipeline's performance, and it will slash your costs. You'll be a hero. But great engineering is a process of continuous improvement. So once you fix your storage and it's no longer the problem, the real question becomes, what's the next bottleneck you're going to hunt down and optimize?